Hi WHS juniors. This MCA review is all about mean, median, and mode, along with the outlier and range. So let's get started with mean, median, and mode. Those are actually called measures of central tendency because there are values that represent typical or central entries in a data set. And the three most commonly used are the ones I just discussed: mean, median, and mode. So they are all measures of central tendency, the middles, what's typically happening. So let's discuss what they are and how to find them. First is the mean. The mean, if you remember, of a data set is the sum of all data entries divided by the number of entries. That means that we are going to add up all of the entries and then divide by how many numbers there were. Were there 10 entries? Were there 25 entries? However many there were. Median of a data set is the middle data entry when the data is assorted in ascending or descending order. So really important, we have to make sure the data is in order before we simply count into the middle and find that median. Now, just so you realize, if there is an even number of data entries, the median falls back to being the mean of those two middle entries. We'll see what that looks like in a little bit here. Last one is mode. The mode of a data set is a data entry that occurs with the greatest frequency. If no data entry is repeated, the data set doesn't have a mode. So just because there's data doesn't mean there has to be a mode. And actually the reverse of that is, if two entries occur with the same greatest frequency, each entry is a mode and the data set is called bimodal. So it's possible to have either no or multiple modes, depending. So mean is when we add up all the numbers and divide by the total. Median is when we put them in assorting order and count to the middle. And mode is the one that occurs the most frequency. So we need to keep those straight. Now, an outlier is something that I like to talk about when talking about mean, median, and mode, because an outlier is a data entry that is far removed from the other data entries of the set. For example, if I gave you this list of test scores, if you notice one test was a 28. I have a dot plot here. All of these test scores landed here between the 70 and 100 range, except the 28. The 28 is really far removed from this other data. It's what we call an outlier. Okay? So an outlier is a data entry that's really, really far removed from the other data entries. And why I want to talk about that is because we need to discuss what kind of effect an outlier can have on a data set. Here we go. If this is the data set I give you, it's those same test scores. If I ask you to simply find the mean, median, and mode of those original test scores, let's discuss how you would do that. So let's start with mean. If you remember, mean is when we add up all the data entries and divide by how many data entries there are. So if you take your calculator and you take 99 plus 88 plus 75 plus 78 plus 92 plus 88 plus 94 plus 75 plus 86 plus 82 plus 78 plus 94 plus 28 plus 88 plus 71 plus 92, we get 1308. And then we divide by the fact that that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 test scores that made up that total. So we added up all 16, and I'm going to divide by 16, and that gives me the mean of 8175. Now, median, I said that we need to put the data in order, either ascending or descending order. So if you notice, the smallest number is 28, and then 71. 75, 75, 78, 78. I've actually gone ahead and done this already. I've taken these exact test scores and just rearranged them. So let's go ahead and cover up the ones that were all mixed up. Let's look at the ones in order now. These are the same data entries, just in ascending order. So the median is the middle entry when we count in. So if we look here, if we count in, notice I land right on 86 and 88 at the same time. That means the median is right in between them. And if you remember from the definition, if the median falls between two data entries, we need to find the mean of those data entries. So what we're actually going to do is take 88 plus 86. I'm going to add up two numbers, so I'm going to divide by 2, and that tells me 87, which means that my median is 87. Lastly is the mode, and the mode is the most frequently occurring data entry. And if I look, this one only occurred once. Okay, that one occurred twice, 3 times, twice. Notice 88 occurred 3 times. It occurred the most often, which means that my mode is actually 88. Okay, so now let's bring in that outlier idea, that far removed data. If you remember from the picture of the dot plot, 28, which I have in order now, is a far removed data entry. So we are going to ignore this 28. We're going to take that outlier out of the data. Notice now if I don't have that outlier, I have only 15 data entries. So if I take these 15 numbers and add them up, and then divide by 15, notice I'm dividing by 15. My total went down by 28 because I took 28 out, and instead of 16 numbers, I now have 15 numbers. So my mean changed. If I divide those, I now have a mean of 85.3 repeating, or 85 1/3. So notice my mean changed quite a bit. It got quite a bit bigger when I took out that one outlier that was dragging the data down, dragging that middle down. Okay, let's look at median. When we have gotten rid of, when we've gotten rid of this 28, let's try to erase it here. It's gone, let's ignore it. Once it's gone, to find the median, we're now going to count in on just this data that we have left over. So we're going to start here on 71 and 99 and count our way in. Notice I land on 88 and 88 alone. No middle one this time. This is the median. That is the middle. So this time our median is 88. And if you look at mode, the most frequently occurring didn't change. 88 still occurs 3 times, which means the mode is still 88. So if we notice, what effect did our outlier have? Well, looking at mean, it got quite a bit bigger. Median didn't change very much. Mode didn't change at all. So which one was the most affected by an outlier? The mean. The mean is the most affected by the outlier in the measures of central tendency. So if we're looking at mean, median, and mode, mean is the most affected by that outlier data. So don't forget, if you're asked something about outlier, to remember that the mean is the one that gets changed the most. Okay. Lastly, I said I was going to talk about range. Range of a data set is the difference between the maximum and the minimum entries in the data set. So range is actually really easy to calculate. We simply take max minus the min. So if I ask you to find the range of a data set, I gave you 15 different test scores. We simply take the max, which is the biggest number. That's not necessarily the first and the last number. Notice in this case, this data is all mixed up. 100 is the biggest number. That's the max. Smallest, 59. So to find the range, we are going to subtract. So our range is going to equal 100 minus 59. So our range is going to equal 41. So the range of the data was 41. That's it. That's all there is to range. And that's all there is to this lesson. So here's what you need to remember. Mean is your average. It's when you add up all the data entries and divide by how many there are. Median is the middle, so you need to count your way in, find that middle. Mode is the one that occurs the most frequently. An outlier is a far removed data entry which affects the mean more than it affects the median and mode. And lastly, range. Range is simply when you take the max entry minus the min entry to see how far apart they are. Good luck.